Now let's look at extension methods.cs file. Extension methods is a static class containing extension methods for other classes. This line number 7, defines an extension method named map2 for the npgsql data reader class. This method takes two parameters, data reader, which is the data reader instance, and entity, which is the object to which the data will be mapped. The method is generic, allowing it to work with any type T. If entity is equal to null, this line checks if the entity parameter is null. If it is, it throws an argument null exception. The next line creates a type accessor object using fast member, which allows for fast access to the member of a type. Entity.getType method retrieves the type object representing the type of the entity. Next, the line retrieves the names of all properties of the entity type and stores them in hash set. The properties are retrieved using getMembers function of the type accessor. The hash set is created using the toHashSet method, ensuring that property names are case insensitive. Next, we have a loop to iterate through the fields of the data reader current row. After this, the line retrieves the property name from the props hash set that matches the names of current field in data reader. Dr get name gets the name of the field at index I in the data reader. The string comparison ensures case insensitive comparison so that there is no issue in capital or small letters. This line number 16, checks if the property name prop is not null or empty, indicating a matching property was found. The line number 17 sets the value of property on the entity object. If this field of data reader is null, the property is set to null, otherwise the value from data reader is assigned to the property. This is all about extension methods.cs. Now let's look at the code of iRepository. First, we import the necessary namespace and define a namespace for iRepository interface within the robot controller API.persistence. iRepository is an interface used for data access operations. Then the line number 8, connection string. This line declares a private constant string, connection string, which represents the connection string used to connect to the PostgreSQL database. Next, the line number 10. This line declares a public method, executeReader, with generic type parameter t. The method takes two parameters, SQL command, which is the SQL command to execute, and db params, which is an optional array of npgsql parameter object representing SQL parameters. The method returns a list of entities of type t. Next, this line number 12, this creates a new list to store the entities retrieved from the database. The next line creates a new npgsql connection object using the connection string constant. The using statement ensures that the connection is properly disposed after use. The next line, this line right here, line number 15, this line creates a new npgsql command object with the provided SQL command and the established connection. Next, the line number 18 to line number 23. This block checks if SQL parameters are provided. If parameters are provided, they are added to the command's parameters collection. Next, the line executes the SQL command and creates a data reader, npgsql data reader, to read the result set. The next, we have a loop to iterate through the result set returned by the SQL command. The next line number 27, this line creates a new instance of the generic type T representing an entity object and calls the map to extension method on data reader to map the data from current row to entity object. Map to is an extension method defined in extension methods.cs that automatically maps data from a data reader to entity object. This line number 29, adds the populated entity object to the list of entities, and at the end, it returns the list of entities populated with data from the database. Now let's see robotcommands.ado file. First, we have the connection string. It defines a constant string representing the connection string to connect to the PostgreSQL database. Next, we have get robot commands. This endpoint retrieves all the robot commands from the database. Next, we have get move commands only. This retrieves only move commands from the database. Next, we have get command by ID. It retrieves the robot commands by the ID given by the user from the database. The next we have get command by name. It retrieves robot command by its name from the database. Next we have add robot commands. This is a post command and it is used to add new command to the database. Next we have a put functionality for update robot command. It updates an existing robot command in the database using its ID and the new updated description of the command. At last we have the delete command. The delete robot command is used to delete a command from the database using its ID. This class uses npgsql library for database connectivity and retrieval, and it utilizes SQL commands to interact with database table. Each method performs a specific database operation, such as inserting, getting, updating, or deleting the data. Now let's get into a little more detail. First, get robot commands. It opens a connection to the database and executes a SQL query to select all rows from the robot commands table. It reads the result using a data reader, maps each row to robot command object, and adds it to the list before returning the commands. Next is get move command only. It retrieves only move commands from the database by adding a condition in the SQL query to select rows where the isMove command column is true. Next we have the get command by ID. It retrieves a specific robot command by its ID from database. It executes the SQL query where clause with a where clause to select a row and matching ID. It reads the result using data reader, maps it to robot command object and returns it. Similar to get command by ID, we have get command by name. It also executes SQL query with a where clause to select a row with the matching name. It also reads the result using data reader and maps it to robot command object to return it. Then we have add robot command. It executes an SQL insert query to add new row to robot commands table with the provided details. Next we have update robot command. It executes SQL update query to modify the details of the command with specific ID in the robot commands table. At last we have the SQL delete query to remove the row with the matching ID from the robot commands table. Now let's look at the robot command repository. This robot command repository class serves as an implementation of both the iRepository and iRobot commands data access interfaces. It interacts with the database to perform various operations related to robot commands. It also has a connection string similar to the previous one, and it has the functionalities of get all robot commands, get move commands only, get command by ID, get commands by name, add robot command, update robot command, and delete robot command. Uh, this class encapsulates the data access logic from robot commands, providing method to perform the CRUD operations on the database while maintaining a separation of concerns and adhering to repository patterns. We also have an execute reader. It is a generic method used internally to execute SQL queries that retrieve data from the database. It takes an SQL command and optional parameters, executes the command, reads the result using data reader, maps the data object of the specific type T, and returns a list of those objects. Now let's look at the robot commands controller. It is an ASP.NET Core MVC controller responsible for handling HTTP requests related to robot commands. First, we have the constructor. It initializes the controller with an instance of iRobot command data access injected through dependency injection. Next, we have get all robot commands. It is handles HTTP GET request to retrieve all robot commands. It delegates the task to the repository command instance to fetch all robot commands from the database using the get robot commands method. Next, we have get move commands only. It handles HTTP GET request to retrieve only move commands. It filters the list of robot commands returned by robot command repository instance to include only those with isMove command set to true. Next, we have the get command by ID. It handles HTTP GET request to retrieve a specific robot command by its ID. It searches for the command with the specific ID in the list of robot commands returned by robot command repo instance. Next we have add robot command. It handles HTTP post request to add a new robot command. It receives the new robot command in the request body and checks if it is valid and adds it to the list of robot commands returned by robot command repo instance. It returns a 201 creator response with the newly added command in the response body. Next we have the update robot command. It handles HTTP put request to update an existing robot command. It receives the updated command in the request body along with its ID. It finds the existing command with the specific ID, updates its properties, and returns a 204 no content response. At last, we have a delete robot command. It handles HTTP delete request to delete a specific robot command by its ID. It finds the command with the specific ID, removes it from the list of robot commands returned by robot command repo instance, and returns a 204 no content response. This controller acts as intermediate between the client and the data access layer, facilitating the CRUD operations on robot commands via HTTP requests. Similar to the robot commands, we have the same functionality for the map. Here is the class and the constructor for the map. This is the map repository.cs where we define the functionalities. After this we have the map ADO. In this we have defined the actual functionality of the working of the methods. Here you can see we have used the same connection string as we have previously used. We have the functionalities of get all maps, get square maps, get map by ID, get map by name, add a map, update a map using put request, delete a map using the delete request, and check the coordinates. This last check the coordinates is also basically a get request. Similar to that, we have imap data access and mapcontroller.cs files. So that's all about the code. Now let's see the output. The commands. First is the get command, which is gives us all the commands that are present in the database. Then we can get move commands that have the isMove property set to true. Here you can see in all the commands the isMove property is set to true. Then we can read the commands using the ID. Okay, so we can post a new command, we can delete a command, we can update the parameters of a command, its name and its move command. And similarly, we can access the maps. Like we can get all the maps that are present with ID 2, 4, 5, 7. These are the IDs of the map and the description they have, and these are the names of the map. Similarly, like robot commands, we can get square maps. Like were able to get move commands. Similarly, we can get square maps. In this, we will get all the maps that have same number of rows and columns. See, same number of rows and columns here, here, 6, 6, 7, 7. These are same. So these are known as square maps. Next, we can read the maps using the ID of the map. We can read the map. ID number 4 map with 3 columns, 5 rows. Name is new map. No description is available. We can update a map similar to the previous one and post a new map, delete a map. And this last command is to get map coordinates. Like in map number 2, the 2, 2 coordinate is available or not. As we can see that it is available. So this is from the Postman side. Now let's visualize the database using the actual tables. Now let's find our actual tables. Here are our tables. This is the map table, first of all. See, these are all the maps that we were able to see in the Postman. This is its a square property, and the number of rows and the columns in the map, the name of the map with its ID. Similar to maps, we have also robot commands. This is the table of the robot commands. The name of the robot command, the IDs of the command, is move command is true or false, the created date and the modified date. This is the actual visualization. The actual data that we run the endpoint there, it gets saved in here.